All right. So, everyone, this is the Grand Green Grabber. It is obviously a symptom of my obsession with alliteration here. But love the idea of putting this together and had a lot of fun building this. So glad I had the opportunity in the class here. It is something I've been thinking about for a while and something that is been very interesting to work on and work with everyone here. So I really enjoyed that opportunity and to learn and to grow while doing so. So a little bit about me. My name is, of course, Matthew Lehmitz, the robotanist. So interests include space, the outdoors, science, technology, building random things, talking about science fiction, all kinds of fun things like that. And of course, for the outdoors right here, this is right outside of cave. We're about to go in and actually start doing some repair work on some of the stalagmites. So that's very interesting day. So in relation to me regarding this, goes back to something I was doing with some of my work previously, or master's, where I was working with drones to fly them up in trees with cameras to look at the plants. And so kind of the next logical step would be to grab the plants or grab a sample of the plants and bring them back down. And so, you slap this onto the drone and it comes along, you have the sample that you wanted, even if it was hard to get. I'll talk about that a little bit more with the summary here. So you get plants from hard to reach places. So we have kind of the cliffside here, the drone going up, looking at it, getting ready to acquire it. And cliffs are one thing, up in the top of a tree over there might be another. Places that, because otherwise you'd have to go tree climbing, which is a difficult challenge in itself. Can be time consuming, potentially dangerous. So if you can have a drone do it, so much the better. So we built a claw and some sensors. So we've got the claw here, the little sides that come together and cut through and hold on to the plant. Sensor suite, which we'll talk about in a little bit more detail, and is included in the video. And we had to develop a structure for it. So there are 3D printed parts that I did in yellow because I like bright, shiny things. And so we designed all of those independently and put them together, and with a lot of glue as well. It's very handy stuff. And work towards, whatever we can learn with this. So we can set it in a lot of different places, use it in a lot of different applications. You can come up with different ideas as you go along for how you could do something with this, flying it over water, picking up other objects. And so it's kind of step one. So the grabbing arm has a blade in it. It's a little razor blade actually just attached. It'll go through the other side. So you have the blade here and it actually cuts through like this, allowing to make sure that we go all the way through the plant base and can pick it up and carry the rest of the plant or plant part back. It's got a camera that records everything visually. So just literally looking at it does exactly what a camera you would expect to do. It's got a time of flight sensor. So we were talking about those earlier, basically a distance measuring system. The further it is away or closer it is away, the more information you have. And it's just giving feedback on relative distance. So you have some idea how close you are to your target. It makes it a lot easier when going in close, trying to make sure that you get the sides or the grasping ends onto the target, since you know about how far you are away. With better information that would be given just by looking at it on the camera, which is a little hard to do, and flying by camera on those little things, you get a little confused. GPS system is on there, so we can map in wherever we're getting a sample or where we're going to a sample and track the movement and destination. So we know where we went and what we did in terms of location. On-off buttons to manage the amount of power that we're using and the amount of distance that the arm is moving in order to clasp. So it goes in and can come back out. So you can actually, even if you miss, go in, come back out, try again. The sensors and feed on the Adafruit dashboard. So all of this is reading out to a mobile platform that you can see on the laptop. You could read on your phone, actually. And it will show all of this in fairly real time, so you can use it to get an idea where you're going. So we can see right here, we've got the cutting blade attached to the grasping ends. We've got the motor that's attached to the bolt running up and down, and you just rotate it and it'll go up and down right through the hole there. The camera hanging out. This is just before assembly. We can actually see right here what it looks like a little bit better. Live button, GPS, and the time of flight sensor would be right over there. All right, and that's one of the challenges. There's so many different parts. They're kind of all over the place and disconnected. And trying to get them all into one cohesive element was definitely a bit of a challenge, because how to make them fit so that they didn't interfere with each other, how to get them so they didn't make it so you couldn't see the camera, for instance, was a problem. Getting all the sensors pointed in the same direction, facing the same direction as the grabbing arm, and making sure they could do so with the wiring. Coding actually occurred in two different places, basically. We had this basic code that ran most of the stuff, and then we had a completely separate code for the camera, which actually ran an entirely different IDE. So that became a particularly interesting challenge to deal with, trying to get those two both going and working together at the same time. And getting the timing right on the motor was a bit of a challenge, because what would happen is you'd start running it, and if you had it going for 2,000 cycles or 2,000 milliseconds, it would just basically shut down, and that's all it would do. And then the code would run again and everything else could get going. So we had to do it in shorter bursts in order to get that to actually work. And 3D printing specific parts that fit in needed places was a good solution to a lot of trying to integrate all the pieces. The camera gets its own little case. You get to put all of the electronics in another. All of the parts are custom designed for the grasper. Rearranging and rewiring various parts. Basically just moving everything around was a big improvement on a lot of it, so they didn't interfere with each other. You have as many wires in weird places. There were a few reprints when things didn't quite align, especially when you're trying to get major wire connections and they didn't go out the holes that you put in. Very obnoxious when they kind of just stick to the side of the case. Pre-installing the camera code to run independently worked pretty well, so we just get that flash and then power it up and run it, have connecting to Adafruit and everything else. Resetting the motor to run in very brief intervals. So instead of running for a second or two, 1,000, 2,000 milliseconds, just run it for 100 milliseconds, and then the code can mostly keep going. It ends up with a kind of jerky motion, but it gets where it's going. Okay, and this is the dashboard we were talking about. So we've got the time of flight sensor going on here. And you can see different distances are shown. Basically, just the closer you are, further you are, you get distance and values. And then we have the GPS coordinates playing out here. Every several seconds it pays out, and you get an idea where you're at. This is what it actually looks like if you're moving around with a little bit. It can be a little finicky and jump occasionally, which is where we're getting some of these odd ones. Like, I didn't quite get on the roof there to do this, but you do get to see what you're doing. Then we have the open and the close. So it'll just spin up and open. If that remains on, then you just turn it off, or the close, the inverse. Nothing too complex, but very useful. And then there's the two different code bases that we were working with. We have the stuff for the camera here. And we're looking at some of the MQTT connection on this. And the code for the green grabber, which you can see the GPS is also connecting. And this became probably the biggest challenge within the code, was making all the connections and making sure they stay stable and we're able to always talk to Adafruit and keep everything going up to the dashboard, because if we didn't have that, we didn't actually see or know what most of the sensors were doing. We also have the STL files. You can see these were customized specifically for this. So we have this one with two uprights. So this is referred to as the static plate, bolts, and a place for the motor to go through. So this is where we have the dynamic or moving plate going up and down through these uprights, and these just stick right there through this guidepost to keep it going up and down, and push the blade through the hole there. And then this is just your fairly standard box, just a modified one to stick all of the circuits into. Those are the sort of 3D files we're using for everything. So in the future, we'll refine design, especially the shapes and mountings, to get it a little bit closer, a little bit better in terms of stability and function. Playing with those 3D files, and the printing will do some more of that. And increase the motor strength is going to be a big one. The motor is just too weak to really move at significant speed, especially with the heavy bolts and other materials, and quite doubly so once you actually get to a plant and try to cut through it. You can get through really soft ones. Anything more than that, it kind of just stops. Reinforce the blade a little bit. It's good where it is, but it could go deeper, and that would make it a little bit more stable. And speed up the rotation. Part of that will just be increasing the motor strength to allow for that. But going faster will actually make it close at a more efficient pace. Work on building a better mount for UAV platforms. So as we're going to be sticking this onto UAVs, or that is the goal, we want to do that. So we need to reduce the weight and also add some nice extensions in order to connect with different parts of a UAV base. Okay. And we have that.
Grand Green Grabber. It is an interesting little project, basically designed to take and hold onto plants as you come in, and you need to pick them up from somewhere. So especially if you have it attached to a UAV or other system, you can basically get them to fly and go to places where they're hard to reach. You can also attach it to other means of travel, such as a rover or other vehicle. You can hold it in your hands and cut things, and it will grasp them. Something really nice when you're dealing with sharp and pointy things. And of course, the real advantage here is getting to places that are hard to get to. So if you put it on a drone and you fly it out to an island or onto a cliff, or even up into the treetops here, where there are plenty of different leaves and things that you can grasp, it will do amazing in terms of getting stuff back. We've got it open-faced here so you can see the components and have a look inside at all the different elements. So in order to do this, we have a few sensors that are attached. Right here we have the camera, which gives you an idea of what you're looking at, of course, just you would expect a camera to. So, and then we have the time of flight sensor, which is this little thing. It's basically a sensor that is designed to measure distances. So we're looking at it going and pinging back and forth the distance to the plant. Okay, and we've got the little button here that controls the motor. So you hold that down, it'll spin, and it will close these, which are kind of the primary section of it. If we look down, we can see that it's got a lovely little sharp blade that will cut through the plant, and we'll show that in just a second here. And then we've got the GPS system right here, which is great for showing exactly where you're at. And we have the main controller right here, which is wired into everything. This little bit right here is basically a control system for the motor, which goes up or down depending on which button we're pushing at the time. So we can come over here and we can see that the time of flight sensor is working just great. We've got 197, 177, and then right here we have the GPS, and it's giving full coordinates, as you can see. And we have actually an image being projected. So we can see the region here and everything, all the GPS coordinates that it's recorded recently, all over around here. It's a little inaccurate, obviously, as we can see here. We're getting from more or less one point, kind of bouncing around, but it's pretty good. Then we have up just above that the stop and start and stop buttons. And if we press those, we get to close or open. And we can do this remotely. So at basically any distance, we have all of these controls and all this information because it's going through to the Adafruit server. We also have the camera over here showing what the camera is looking at, being really useful. So let's go ahead and demonstrate really quickly while we've got it here. We've got it outside so we can see more or less what it's capable of. And if we put that right in here, as you would expect to be cutting through the plant, you can just get it under there. Okay, and then press down, and you can see that the screw is rotating, and that forces the arm down, and it cuts right through the plant that it's targeting. Okay, and then we can pick up and carry the plant away as needed. And that is the Grand Green Grabber. We hope you enjoyed today's demonstration, and we look forward to the opportunity to talk to you again.